Okay, so data visualization with ggplot2. We also did that. We looked at the three elements of ggplots. Can anyone remember some of the things we spoke about the elements of ggplot? I spoke about three main elements of ggplot that you need to help you do your visualizations. Yeah. Data. Okay. Anyone else? So you need your data. What else do you need?
Aesthetics.
You need the aesthetics. Okay, good. All right. You need the aesthetics. And what else? You're not sure? Geometries. Okay. Okay. So people say geom, and say it's geometries. The geom stands for geometries. Then the geometry will determine the type of plot you want to plot. So if it's scatter plot, we use the geom point. If it's box plots, geom box plots. There are so many types of geoms. And I sent you the cheat sheet for ggplot. So just play around with it. You see various visualizations. Once you understand the basics or the mechanics of ggplot, you can do any type of visualization that you want. Okay. All right. And then we also moved on to association rule mining or association rule learning. All right. And then we spoke about the fact that it is an unsupervised machine learning method. Okay, one of the unsupervised machine learning methods. And it is used to gain insight into our data, especially when we don't know anything about the data. Okay, so the a priori algorithm helps us to know the associations or how the item sets within the data are related. Okay, and then we looked at the three main parameters of the algorithm. Yeah, what are they? Support, confidence, and then lift. All right. So we said that the main, you can have good support, you can have good confidence, but if your lift is, let's say, equal to 1, that means that there is no relationship between the item sets. Okay, so we want a lift that is more than 1. So ideally, you want the one with the highest lift. Okay, the one with the highest lift. Okay, however, so in theory, you want to choose the parameter with the highest lift. Okay, but in practical terms, you could have 2 lifts that are very high, and then other aspects might come into play, like the support and the confidence, and then you decide on the field as to the best course of action. So we started with the theoretical part of the association rule mining. So today we want to, like, if you will, get our hands dirty to see how we can do it practically. All right. Then from there, we will move on to other unsupervised learning. We'll look at clustering today. So we'll look at the 2 main unsupervised methods, that is association rule and then clustering. All right. And then we'll be done with this model. Then we'll move on to the next. Any question? Any question? Any questions so far? Yeah? Okay, so let's move on to, yes. So when you ask a question, the people can't hear. So I'll have to repeat it, isn't it? We don't have a microphone here, so yeah. The ggplot, yeah. Okay, so one thing I want to tell you, so you were asking about the pie chart. You didn't see anything on the pie chart. Okay, so please, for data scientists, pie chart is a no-no. Okay, for data scientists, pie chart, it doesn't give you any insight. Okay, it doesn't really give you any insight. Why is that? If you compare 2 pie charts, one looks very small, one looks very big. Okay. How can you compare the two even if they are in percentages? Okay. The fact that something is small, okay, like a section of the pie chart, let's say 3%, it's small, and another section of another pie chart is quite huge. Visually, it doesn't tell you that the one that is huge is bigger than the one that is small, because the one that is small might be huge in terms of percentage, but because it has several sections in there, it is small. I don't know whether you get my argument. Okay, so visually, we don't normally, we will prefer a bar plot. Okay, this is taller than this. Visually, you can see it and then make inferences into it. But pie charts, as much as possible, avoid it. Okay, so I'm not surprised that you are not getting anything on pie charts. Okay, so data scientist pie charts, leave it for the normal business business people. Okay, so pie charts, please, as much as possible, don't visually it is you don't get any insight from. Okay, yeah. Please, any question? Any other question before we move on? Please, Kumasi people, did you hear me what I said about the pie chart?
Yes, we.
Okay, so
Yes, sir.
As much as possible, don't. So even in your, so now that you know in your thesis going forward, please don't be doing pie charts. Okay, you are a data scientist now. Okay, don't be doing pie charts. All right, you have other ways of representing data that is more intuitive than pie charts. Okay. All right, so let me share my screen. Yeah.
Hello, sir.
Yes.
Yeah, before we start, the lineup.gz, it doesn't open. I don't know why.
Yes, you can't open it. It has a special file extension. I will show you how to do that in our.
Okay.
It's not every time that you'll be dealing with CSVs. So as we go on from our session today and other sessions, I'll be introducing you to other various types of file formats. Okay. All right. Okay. So, yeah. So we want to look at association rule. Association rule learning or association rule mining or association rule analysis. Okay, so there's a special package that you need for the association rule. It's called the A rules. Okay, so let's install it. So install the packages. A rules, association rules, okay? And then you also need to install, we need to visualize it, okay? So you also need to install A rules vis. So A rules vis. All right. I have it already, so I don't need to install it. So you install it first. Okay. I'm commenting it because I don't want to run it. Okay. So you run it on yours. And when you are done, call it from the library. So I'll call my A rules, and then I call my A rules base as well. Okay, run it. Let me know when we are done with the installation. When you are done, import the shopping cart. The shopping cart data sets are put in the on the platform. Yeah. Okay. Let me find out where I have it. Do I have it? Shopping carts, yeah. Yeah. So when you copy the file path, you change the slash to front slash. I'll show you other ways by which you can import. Okay. At least let's master on this one first. Let me move this one. Yeah. So remember, it's a CSV file. So let's just read it. Read the CSV. Okay. So let's name this AG. Then we run it. Please, are you done with the installation? Okay. So just import the data. Then let's see what we have here. Okay. So it's just a simple data set on our sales. So we've sold bread, butter, milk, Milo, Coke, chicken. Okay. So I'm just using numbers to represent whether for a particular transaction something was bought or not. So if it is 1, that means that thing was bought. If it's 0, that means that. So for instance, if you take transaction 1, okay, transaction 1, this guy here, okay, transaction 1, this guy here, he bought bread, butter, he didn't buy milk, he didn't buy Milo, he bought Coke. So he bought only 3 items, okay? So that's what this means. Please, is that okay? Okay, so if it's 0, that means that that person didn't buy anything. So we have, about 10 transactions, okay? We have, 10 transactions and giving us various things or various items that were bought. Any questions about the data set? Any questions about the data set? You are still installing. No problem, we'll wait for you. Oh, am I not sharing my screen? Please, are you seeing my screen, Kumasi?
Yeah, we are.
Okay,
Yes, we can
Christiana,
see.
yes. Can I help? Christiana,
but
how
we are
you
still
doing?
installing.
Please, sir.
How you
My
doing?
installing with. I'm fine, sir. Thank
Okay.
you. Please, my installation is telling me it could not find function install packet install dot packages.
You can't install it. You're having problems installing it.
Sir,
Yes,
I had
sir.
the same thing, but Christiana, try and check the spellings.
Check the spellings. It's A rules, okay? It's A
Okay.
rules. A
Check
rules.
the
Association rules.
Okay. Okay. Sir, it's the same thing.
I think I should join the
Okay.
WhatsApp on here so that you can hear what they are saying. Yeah.
Okay. The install is what capital I. Let me see.
Christiana, as for the installed or packages, we did it last week. So by this time, you should be conversant with it.
Yes. No, I typed it wrongly. So I'm very grateful. It seems it's working now.
You still cannot hear them. It's very faint. Okay, so it's okay if I use it. I will repeat any question they ask me.
And also, so are we all set? Has it installed? If you are done with the installation, then call it from the library. You are done with the installation, call it from the library. Okay.
Please, sir.
Yes. Yes, Christiana, go ahead.
It's still installing, but the first one went through successfully.
Okay, so you are now installing the A rules base.
When I called the library. Yes, sir.
Okay, all right. We'll wait for you. Please, any questions on the data set? Any questions on the data set? So when you are done, the shopping cart that I put on the platform, you can import it into R and then read it as AG. Okay? Read it as AG. Now, this is a normal data frame. Okay. Yes.
But when I finished installing it and I was loading it, an error message came. It said the package is maxed.
The package is what? It's not active.
It is maxed.
That means it hasn't finished installing. Let it finish installing. Okay, share your screen and let me see what your system is telling us.
Yeah.
Did you install the A rules base?
Yes.
Okay. But why don't you write it? Why are you writing it in the console? Why don't you write it in the editor, the library, A rules base? Because if you do that, you cannot keep a record of it. I explained this to you the last time. So whatever you've done in the console, go copy it and paste it in the editor and then run it again.
I didn't do it in the console. I did it in the editor, and the response came in the console.
But where is it in the editor? I can't see it in the editor. You only have up to line 3. There is no line 4 for the library. Where is it? That is the editor.
Did it in this one.
Or did you delete it?
I didn't delete it. It just came this way.
Okay, so run it again. Run the A rules, and then when you finish, you run the. So just click on what is giving you. Yeah. So run the A rules, and yeah. Yeah, it has run. Everything is fine.
That's run now. Yeah, thank you.
Okay. Okay. All right. So this is a normal data frame. Okay. But we need to convert it in a way that the a priori algorithm will be able to read it, recognize it. All right. So we need to convert this into a matrix. Okay. We need to convert this into a matrix. So when we convert it into a matrix, based upon that, then we further convert it into transactions. Then it will read it as transactions, as if it is reading it from a database. All right. What we have now is just a normal data frame, and we wouldn't get the insight that we want from it. We wouldn't be able to apply the a priori algorithm on this one. So first of all, let's transform this into a matrix and then onto transactions. And then we can apply the A rules on it. Okay. So let's name this AG1. Okay, we're going to name it differently. So we want to convert this as, so the AG1, we want to convert this as a matrix, okay? So as dot matrix, okay? And what do we want to convert? We want to convert AG. You remember, that is the data frame, okay? So we are converting this one, yeah? The AG, which we've done here already, into a matrix, and then we are naming it AG1. Is that okay? Okay, so let's run it. So now when I call AG1, it will be in the form of a matrix. Okay, see AG1. If I run it, you see that it is now in a form, though it's the same information, but you see that it's a form of a matrix. So now it recognizes as a matrix. Is that okay? Now, once we've converted this into a matrix, let's further convert it into transactions so that it will read it as transactions. Okay. We can still keep the same AG, okay, and then convert this AG1 and then convert this into transactions. So AG1, okay. What we want to do is to convert this into transactions. So as the first argument is AG1, which is the matrix, and then we want to convert this into transactions. All right. So let's run this. Yes, Bernard, is there a problem? I see your hand raised.
Yes, Nana.
Yeah.
I want to share my screen. I'm having some error. I don't understand.
Okay. Okay, go ahead. Go ahead and share your screen. Let's see. Please enlarge it a bit. I can't see anything. A Rules vase. Please, the vase is capital V. Check it. Okay. So when you're installing, yeah. So
Thank
do
you.
it and come back.
Okay, Nana.
All right. So please, are we okay here? Yeah, no, okay. Okay. So just hold on, I'm coming around. We don't want to leave anybody behind. Okay.
You want to use a relax one and make a major in one touch. You didn't. Said I'm getting error. I'm like, I don't sort this WhatsApp number. All we have is calling number. So I'm getting error. I just left the class.
So the installation, that means that the installation, did you install it? Yes, so check how you installed it. It should be the same spelling. Okay, you see that it's capital V. Aries V. Oh, this place is not clear enough. All right. Are we okay? Bernard, your hand is still raised. So once you've sorted you out, please put your hand down. Yes, Francis.
Yeah, Doc. Good morning.
Good
My
morning. How
question,
can I help?
yes, my question is, why is there a need to convert the data set into a matrix? And also, what is transaction? What function is it? What does it do? And why
So,
must we?
all right. Okay. So first of all, what we had earlier on, the CSV file that I gave to you, R sees it as a normal data frame. All right. Now, based upon the algorithm we are going to use, that the a priori algorithm, it does not read data frames. It only reads transactions. All right. Okay. So we need to have our data in the form of transactions. So if we were importing straight away from a database, then there wouldn't be the need for us to convert the data frame into a matrix and then transactions. Because I did this from scratch, that's why you are seeing it like that. But we are going to take an example where we will import straight from a database. We will not need to convert anything into transaction because it's already in the form of transactions. Is that okay? So that's why we converted into a matrix. Because for you to be able to convert to transaction, your form has to be in a matrix.
Okay, I understand. So it means transaction is an object like our object type, just like
so transaction is like it helps out to read it as if you've gone to buy something and the way it's been recorded that you bought bread, you bought this, you bought this. Okay, so it helps out to see it that way because we are going to generate some rules out of this. Okay, and if it is in the form of a data frame, it cannot be able to do that.
All right, that's fine.
All right,
thank you.
Okay, you are welcome. So are we all on the same wavelength now?
No, sir.
Okay, give him praise. Yes.
Sir, please.
Yes,
I'm having error running my install package and library.
Okay, so the install package, which one did you run first? Did you install first? Is it the A rules?
Yes, please. I installed the A rule first.
Is the A rules working?
Please, it's just showing. It's showing, but there was no download. I don't know. There was no input.
Give him praise. Okay, share your screen. Let's see. Please, we are waiting for you.
Okay.
Okay, so install the package. Why did you comment it? You shouldn't have commented it. Line 2 and 3. I commented mine because I already have the package. So I don't need to run it. So remove the hash tag there. Because I didn't run it. Yes, so remove it and then remove the other one. Then now you can run it. I put a hashtag there because it wasn't. So install that packages here. A rules you should run. So run number 2. The A rules, please put A rules in inverted commas, okay? Just like you did for A rules base.
Okay.
So whenever you are installing packages, put it in inverted commas, okay?
Yes, please.
Okay, so now you should be able to run. Yeah?
Okay.
And then run your A-rules vase as well. After you've done that, then you call it from the library. Let it finish downloading. So it's still downloading, it hasn't finished. Please, are you okay here? Should I come?
Please, is it still downloading?
Yeah, it is.
Give him praise. Yours is still downloading, yeah? So
Yes,
let it
please.
download and then
Okay.
I'll come back to you. Okay.
Okay, thank you.
So let me go over what I've done. Okay. So first of all, I installed the package. Please, I just put a comment here because I didn't need to run mine. I was just using it to illustrate to you. That's why I put a comment there. So if you put a comment there and then you run, it will not run. Remember that when you put a hashtag, it tells R not to run. So that means you are putting a comment into the program. Yeah. Okay. So when I did that, I called it from the library, A-rules and then A-rules vis, because these are the two main packages we are going to use. After that, I imported my data from wherever I had it. Okay, brought it into R, read it into R. Okay, and after that, I converted it into a matrix and then to transactions. So now R is seeing AG1 as no more as a matrix, but as what? Transactions. Please, any questions so far? Are we okay? Are you okay there? Okay. So now, yeah,
please,
I
have a question.
Yes.
Yeah.
Yeah, after loading everything and calling the library, it is showing that loading requires package metrics.
So just click yes, okay? Just click it, it will load it for you. Okay.
Okay.
So mine is the syntax. The is it a built-in syntax?
Yes, it's a built-in syntax. Yes.
Okay.
As matrix. Okay. All right. So let's fit the model. Okay. So now everything is set for the a priori algorithm. Okay. So let's fit the model.
Hello, sir.
Yeah.
Sir, please, mine is not, it's giving me an error in AS. No
Yours
method
is
of the
giving you
first
error
copy.
in AS.
Yes. I'm at the
Okay.
transactions. Should I
Which
say?
one is it? Is it giving you errors as in the
Into
matrix?
bracket AG1.
Okay, share your
Yes.
screen. Let me see. Share your screen. Let me see.
Okay, sir.
So you're having an error.
Okay, sir.
Share your screen. Let's see quickly. Please,
Yes,
let's hurry up and then move ahead. We have a lot of stuff to cover.
So I'm having the same problem too.
Okay, so let him share his screen, and we use one stone to kill so many birds. So it's as dot matrix, not s dot matrix. Okay, line 15.
As dot.
Line 15, not 20. Line 15. Yeah.
Line 15.
Yeah. You've written s dot matrix.
It's supposed to be S as.
It's as. No, remove the s. Remove the s.
Okay.
Hey. Okay, so you are fine now. Okay.
Yes, thank you very much.
All right. Okay, you're welcome. All right. Any other?
Yes, sir.
Okay. Share your screen. I thought you said it was the same thing. So if you have...
let me share my screen.
I think next time they need to set us up so that you can hear what they are saying. But they have errors, so we are dealing with errors. So you don't have errors, so don't worry.
Sure.
Accra people don't have errors.
Hmm.
All the errors are coming from Kumasi. Okay, please go ahead.
Yes, sir. So I keyed in this one, the AG1 ASJG1 transactions, and this is what I got the error.
Okay, run the matrix. Let me see. You see, when you are running the matrix, you have X in there. You shouldn't have any X in there. As matrix, it should be just AG.
So I don't get it.
Oh, okay. Just a minute. I'm not seeing your screen well. So matrix, and then okay. So run it and let me see. Run the matrix. Okay, call AG1. Let me see something. Okay, so it's now in the form of a matrix. Okay, and then you were running this, and then you were having problems.
Yes.
Check the inverted commas whether they are all in line. So as AG1, comma transactions.
Okay.
How?
Okay, so run it.
How?
So the same thing.
You work class, may you online, dear.
Let's see.
You eat your cocoa.
I don't know why it's giving you that problem. Let me see. This one. Asymmetrics. When you were running the packages, did you have any issues?
No, I didn't.
Okay. I don't know why it's not working, but don't worry. We will do another one which does not involve you using the matrix. I don't know whether because the matrix is working, so I'm wondering why it's not able to coerce it to become transactions, because everything seems correct. Or you want to quit and then come back to R and then try it again.
Okay,
or you can just wait. We will take another example which you don't need to take.
Okay.
Yeah. All right. Okay. All right. So let's go ahead. So now that R recognizes this as transactions, let's fit our model. Okay. So we use what we call the a priori algorithm. priori algorithm. So we want to convert AG1. Okay, we want to build the rules for AG1. And then it has an argument for parameter. Okay. So this is where you specify your support and then your confidence. Remember that what we did last week, we said that when it doesn't meet the minimum support threshold, it will discard it. Do you remember? When it's doing the iterations. All right. Okay. So this is where in this argument, this is where we set the parameter for the minimum support and then the minimum confidence. So any item set that does not meet that support or the confidence, it will be discarded. Okay. So let's set our minimum support. So we put this in a list. Okay. So our support, let's make it 0.3. We can change it as we go along. Okay. You can play around with it. And then our confidence, let's make it 0.5. Okay. So let's name all these rules. Okay. Please, are you following? So now we've converted everything into transactions. All right. And now we want to apply the a priori algorithm on the transactions to give us insight into the data, whether there are some associations or not. Okay. But to do that, we need to set our minimum threshold for the support and also for the confidence. All right. So when we do that, it will use this criteria in generating the rules or the relationships between the item sets. Okay. So now that we have this, let's run it. No, you determine the level of support that you want. Last time we learned how to calculate the support and then the confidence and then the lift. It was just to show you how it is done. But I will do it for you. You don't need to calculate it. All you need to do is to specify that I want a confidence level of 30%. And then I want a support level of 40%. Those are your minimum thresholds. But last week is just for you to know how to calculate it so that when you are telling R, you understand that support means this, confidence means that, okay? So here we are setting the minimum support. So, okay, so the parameter is a minimum threshold of 30% for support and then 50% for confidence. Okay, so let's run this. Okay, now, please pay attention. Now we've run the rules, okay? Now, if you see the output in the console, you will see here that it has, forget about everything that is, just concentrate on where it has the rules. So it has generated 16 rules, okay? So it has generated 16 rules. Now let's inspect these 16 rules, all right? So here, we'll come back. When you change the support and then the confidence, it will affect the number of rules that will be generated. So if your threshold comes down, then more things will be included. If it goes up, then many things will be discarded. I mean, you get how it works, yeah? So let's inspect the rules. So inspect rules. Okay? Inspect rules. Let's name this, okay. Let's just inspect rules. Okay, so you see what we are getting here. All right, so based upon, so you can see that we have rules up to number 16. Now let's check all of them. So we have the left-hand side or the LHS or the antecedent, okay? And then the right-hand side is the consequent. Do you remember? Last week we talked about the antecedent, that is the A, and then the B, arrow B, consequent. All right? So it's the same thing that we have here. The antecedent is the left-hand side, LHS, okay? And then the consequent is the right-hand side. Please look at me and let me see if you are following. Look at me and then you go back. For those of you who are in Accra. Okay, so now, based upon the threshold that we set, okay, based upon the threshold that we set, the minimum threshold that we set, okay, now we are getting, for each transaction, we are getting the support, we are getting the confidence, we are getting the lift, okay? Forget about the coverage and the count. I will explain that later. But the main thing here is the support, confidence, and then lift. So for all the items, for the 16 transactions, it has calculated the support, confidence, and then the lift. So now you have to determine which item sets are very much related. Remember that we are looking for the one with the highest lift, okay? So if we want, we can rearrange this so that the highest lift will start and then it will reduce as it goes down, okay? So let's rearrange it. So let's rearrange the rules based on the lift. Okay. So let's call this AG2. So what we want to do is to sort this. We want to sort these rules, okay? And then the rearrangement, we want to sort it by lift, okay? We want to sort it by lift. And then it should start from the highest to the lowest, so it should be decreasing, okay? So we set the decreasing argument to true. So let's run this. So now that we've run, let's inspect AG2 now, okay? Okay, so now it's arranging it by lift. Okay, so you see that the one with the highest lift is now starting. All right, so which means that those who bought Coke also bought butter. Okay, and it's giving us a lift of approximately 1.7. Okay, and then followed by butter and Coke. All right, they are not the same thing, but it's giving us the same lift. Followed by the third transaction, that is anyone who bought Milo also bought chicken. Okay, so it does the one item sets. So here, Bailey is doing just one item set. Okay, we'll take others that involve other item sets. So based upon the threshold that we set, you see that it's giving us this insight, which means that if you are arranging things in the shop, Coke and butter should be at the same place. Okay? Or if you are doing a promotion, make sure that you involve Coke and butter, because people who are buying Coke are also buying butter. So these are the associations. So it could be related to anything. It could be the number of clicks on the website, how people visit this place on the website. From here, they go there. So you can rearrange your website, okay, based upon the lift that you are getting, combinations of the lift that you are getting. Have you seen? It could be arrangement in your shop. So these are all insights you are getting into your data. So the first data, the raw data that we had, we didn't know that people who bought Coke also bought butter. We didn't know. But the a priori algorithm has given us insight into this data. Okay. Now, play around with your support and then the confidence and see whether it will change. 11. Transaction 11. Okay. Okay, rule 11, yeah. So it means that the person just bought bread. Yeah. Okay. So there wasn't anything at the left-hand side. Okay, so play around with the support. Let's reduce the support to 20%. Okay, and then reduce the confidence to, let's say, 40%. Okay, let's run it again.
Originally, the code was meant for the professional bankers, those who have gone.
Have you seen that now we are having 51 rules?
All the examinations conducted by
all right,
bankers, and they
okay.
call themselves the chartered bankers.
When you reduce your support and then the others, so you see that this one given us 51 rules. Okay, so you see that as the rules increase, now it's taking on more item sets. We are having the last one, for instance, we are having bread, milk, chicken. So people who bought bread, milk, chicken also bought Milo. Okay. Let's rearrange this and then see. Please, can you turn off your microphones? Okay.
So that our banks will attract the customers.
Can you see the person doing that? Is it?
Hello, someone.
Be a corporate responsible organization.
Please call her and let her mute her phone.
I'll pause for any question before we can continue. If anybody has a question.
All right, so here we see when we generated 51 rows, so we see that the item sets have increased, okay? So now we have 2 item sets and also 3 item sets. All right, okay? So the highest left is 2.0, 2.5. So here, people who bought bread and chicken also bought Milo. All right? Any questions on this? On the a priori algorithm? A priori algorithm. Any questions on this? Okay, let's take a live data set.
Nana, please, I have a question.
Yes, Muslim, go ahead.
Per what we are doing, it means that depending on our support and confidence, that's when the iterations will be done based on.
Exactly. That's what I explained last week. Yeah.
All right.
Okay. So the more, as you increase the threshold, the more things will be discarded. As the bar comes down, you lower the threshold, the more things will be included. Okay.
All right. Thank you.
All right. Now there's a built-in database in R. Okay, and for a data set called groceries. So for built-in data sets in R, you start with data, okay? You don't need to import generally like we use the set working W. So let's import it. So let's import groceries. Let's import groceries. Let's run it.
We can't hear you.
No, I haven't spoken yet. So if you look at this transaction, it includes 9,835 transactions. Okay, so let's have a look at them. Let's inspect the groceries. So you see that now, because the grocery is coming from inbuilt database, there's no need to convert it into a matrix. Okay, so we can just inspect it straight away. Okay, so let's inspect the groceries.
Wow.
Okay, so this has given us 9,835 transactions. Have you seen it? Okay, so if you scroll up, you will see all these transactions. So these are items that were bought. Okay, these were items that were bought from a particular shop. Okay, so item 9,831, the person bought sausage, chicken, beef, hamburger, meat, citrus fruit, grapes, and so forth. Okay, all right. So let's see how some of these item sets are related. Okay, let's see how some of these item sets are related. So let's apply the a priori algorithm. Okay, so we want to apply it on the groceries data sets. Let's set our parameters. So we have a list, and then we specify our support and then our confidence. Okay. So the support argument, let's make it 2.02. We can play around with it later. And then the confidence, let's say 0.3. So let's call this groceries 1. Okay. So let's run this. Okay, so you see that this one is giving us 37 rules. Have you seen it? 37 rules based upon our minimum threshold for support and confidence. Our support is 2%, and then our confidence is 30%. Okay. Right. So once we've done that, let's inspect our GR1. Okay. Let's see what it comes up with. Okay. So let's do this to the other side. Let's run it again. Okay, I want to see everything. So let's wrap this whole thing in view, okay? So view, and then let's come and put this whole thing into it so that it can open another tab for us, and then we can see everything. Okay, so here we can see everything. So we have our support, confidence, and lift for about 9,000. Oh, sorry, for the 37 rules that have been generated. Okay, so here, what we are saying is that people who bought frozen vegetables also bought whole milk. Okay, so it continues here. So let's rearrange it To the top. Yeah. Yeah. I'm in the editor. No, I'm not. I've opened another tab. I want us, because you see the one in the console, some of the information is down here. So you have it here like that, but after the coverage, there's supposed to be the left and then the count, but it's not showing. So that's why I opened it here. But we can just go back and then look at it from here. Yeah, no problem. So why don't we rearrange it so that the highest left will show and then we can gain some insight? Okay, so the same thing. Let's just copy this. Let's just copy this and then bring it over. No, I'm saying that let's rearrange it so that the highest left will start. Okay. So this one is GR. Let's make this GR2. Okay. So everything stays the same. Change this one to GR2. So let's run this. And then we inspect again. So the one with the highest left. Oh no. We are sorting the GR1. Let's see the one with the highest left. Okay, so let's look into view so that we see the whole thing. This one doesn't cover everything here. So let's come and put this whole thing into view so that it opens another tab for us. So the one with the highest left basically is people who bought other vegetables and whole milk also bought root vegetables with a lift of 2.84. All right. So these are some of the insights you can get into your data with your a priori algorithm. Yes, Felix, your hand is raised.
Yeah, when I ran it, I had an error.
When you run what?
The view inspect groceries.
No, you shouldn't have an error. Did you use capital V?
Yeah.
So just copy what you have in the inspect and go and put everything into the view. It should run. Probably okay. You don't have your brackets are not closing well.
Okay.
Please, any question? Any question? Any question? Any question?
Nana, please. I'm not able to get the table. Even with the capital V and everything.
Okay. Share your screen. Let me see what's happening.
Okay. Please, a minute.
Please, are we okay here? It's important to be okay here. If you are not okay here, then you are in
Nana
trouble.
still.
You share your screen. Share your screen. Let me see. Okay. And let me see if I can help. You have to be okay here before you leave. Other than that, we are in trouble.
Okay, so Nana, this is it.
Yeah, by that. Okay.
I'm not getting the table.
Okay, go back. So run your Run your line 31 again. Let me see. 31. No, sorry. 39. So everything is fine here.
Yes.
And then when you try to view it, it doesn't open.
No, the table doesn't come.
Okay, but the arrangement has been done according to the left. Go to the console and then go up. Let me see the one with the highest left. No, don't go to up. It's where your command started. Yeah. So the one with the highest left is 2.84, just like we did.
Yes.
Okay, but just that you are not able to view it in another tab.
Yes.
Okay, write it again. Write the code again for the view, line 40. Just write it. Don't write it. So view into brackets. Okay, inspect. Okay, into bracket GR2. Okay, run it again. Let's see.
Thank you very much.
Yeah, okay. Yeah. Or is the one that is starting, isn't it? When you rearrange it. It's the same thing, the one with the 2.84. Okay, let's see. Bread and chicken. Hey. Did you use the same thresholds that we use? Check our support was 0.02. Confidence 0.3. 0.3. Check it well. Yeah, Christiana, your hand is raised. Christiana, your hand is raised. Okay.
Please, can you hear me now?
No, I can't hear you. I just heard you that. Okay.
Please, I'm lost.
Okay, where did you get lost? In the
I will say from
wilderness.
the beginning.
No, you can't
Is
say
this
from the
another
beginning
problem?
because
So
you had some
when
other
we
issues
when we
dealt
go
with
on
it.
break, can you please stay and help me a little?
Okay, when we go on break, that's fine.
Okay.
Please concentrate. Oh, I see some of you watching your phone and stuff like that. uh, okay, any questions? Anybody needs me to come around? You are stuck on anything? You want me to have a look? Yeah? Okay, just a minute. What the one with the head? Oh, let's see. Oh, okay, because the lift is down there. Okay, let me use the view. Let me use the view. I think I have the view here. Okay, so let's look at it. The view is actually other vegetables and then root vegetables. Yeah. Then what do you have? No,
one you are going to use, I think this is the one we use for the other one, for the structuring card. Let's do it. Now, right. Right. We've given you the shopping cart information because I think in the problem, so yeah, you are used GR1. Yeah. Yeah. Okay now. Are we okay here? Okay, good.
Please, you can't hear. I can't hear anything.
I think he's sorting some people out.
Oh, okay, okay, okay.
Okay. Any question? Any question? Okay, so let's go for please, Kumasi, are we okay? Any question?
So we are.
Okay, so it's now 10.
Please, I'm not okay.
Yeah, we said that I will sort you out during the break time, isn't it, Christiana? Christiana? Hello?
Sir.
Can you hear me?
Please, sir, yeah, I can hear you, sir.
Yeah, you said you wanted me to sort you out during the break time, isn't it?
Yes, sir.
So let's
So, sir, okay.
Okay, so let's get something to drink. Let's come back 11 o'clock. Okay. Then we go for our main break. This for drink, it's not for food. Okay, Christiana, please, how can I help?
Please, sir, from the installation.
Yes.
From the beginning.
From the beginning, okay, no problem. Let's go up. Can you see my screen?
Yes, sir, please.
Okay, so yes, share your screen. Let me see the troubles you're having.
I've closed it, so I've opened a new one, so I'll share it with you so that.
Okay, no problem.
Please, sir, can you see my screen?
Okay, so good. So you want to install the A rules. So A rules,
yes.
There's an S. So yeah, so run it.
I should run it.
And put it in inverted commas. Put it in inverted commas. That's why you are getting problems. So it tells you that the A rules cannot be found. Run it now. Okay. And then run the A rules base as well. So when you are typing and it comes, yes, just click on it and then A rules base. Also in inverted, good. A rules. The base is capital V. Capital
like
V. Capital V.
The V is capital.
Yeah. Okay. So wait for it to install. When it's done, before you call it from the library.
Sir, please, when you're done with Christiana, can you check something for me?
Is that the last?
Sir.
Okay, no problem.
Okay.
Please, has it finished?
Yeah, so it's done. So so call it from the library now.
Please, the loading metric required, should I leave it like that, or is there a problem with it?
Just a minute. So it's not done yet. You see, when you are downloading and you see that red thing on the console, that means that it's not done yet. That's now finished. So take your time for it to finish. Okay. So now call the library ARUS Vis. Yeah. Okay, good.
Please, that means it's okay.
Yeah, that's fine. So get the other ones we've done and then run it. Okay.
The other ones. Okay. So actually now I'm not coming to install the data.
Yeah, so import the data that I sent to you. So
okay, so
so you can get the script from your colleagues, or when we finish, I'll send you the script that we've done for this session.
All right, sir. Thank you very much.
Okay, you're welcome. Yes, who else? Was that the last who was asking the question? Please, who was asking the question? Somebody wanted me to help.
Please, it was me. Please,
Oh,
I'm
giving
coming.
praise. Okay, how can I help?
Sir, please, I'm coming. Please, can I share my screen?
Yes.
Class phone ekasana. Me class phone ekasana. Me class phone omukasa.
Sir, please, when we got to the number 9, I was running the AJ. It wasn't running, so I decided to skip it and go and copy the rest of the code.
You say when I was running, when you were okay, it didn't run.
Yes, please.
Okay, there's an issue here. Just go to your console. You see where your console, not the editor. The last one, I can see some 3 comments there. No, your console. You are in the editor now. Go to your console, down. The last one.
Yes, please.
Yes, you see where you have the 3 hashtag, or is it 4?
Yes, it's 4.
Click on it. Put the cursor there, and then click on escape. Escape on your keyboard. Yeah. Okay. Good. Fine. So come back to your line 9. Okay. So yes, import it.
So you said I should run it.
Yes, run it. You want to import it, isn't it? You want to import the AG. Is that not
yes.
so? Yes. So set the working directory first. The working directory, is it in downloads?
Yes, please.
Okay. Probably later you need to find a place where you keep all your R stuff. Okay. Don't put it in downloads, so that when you set a working directory, it will always go there.
Okay.
Okay. Instead of using downloads. Okay. So for now, this is where it is set. Okay. So set your working directory. Run line 8 again. Yeah, and then run your AG. Yeah.
Okay.
So now turn it to a matrix. So first of all, it's AG1, okay, as dot matrix. Okay.
So you said AG. Sir, please, I have someone that sent me the code, so let me copy
Yeah,
it.
so run it. Yes. So the one they sent you, run it, and then you should be fine. Yeah.
Okay. Sir, please, if I have any problem, I'll share it back.
Don't worry, I'm here. We are here the whole day.
Thank you.
Hi.
Okay. Yes, Pius,
Please,
go ahead. Please wait. Somebody's asking a question. Pius.
Good morning, Anna.
Yes, good morning, Pius. How
So
can I help you?
I'm confused about the source of this groceries data that we are using. Where is it from?
The groceries it's built in R.
Okay, because I was confused. Thank you.
All right, okay. Yes, Christiana.
Please, when I copied to the set, is it my set to call the file? It's giving me something unexpected error in set word.
So your file path is not correct.
Hmm?
Check the file path. Where did you save it?
When I downloaded it, I saved it. I have a folder.
Yes, so go and copy the file path of that folder. Okay, share your screen. Let me see.
Okay. Please, can you see it now?
Okay. So when you set working directory, and I told you when you set it, change the backslash to front slash. You forgot it.
Oh, okay. Thank you.
You can make a comment. Make a comment there after the library. Okay. After the library, just calm down. Create a space there. Yes, and make a comment that change, or when you do set working directory, change backslash to front slash so that you can always remember. Okay.
Thank you, sir.
Remember, when you are doing your coding, you can be commenting in between so that when you go back to it, you can always remember what you've done. Okay, so change front slash to backslash, backslash to front slash so that you don't forget. Okay. Yeah, Nehemiah, yes. How can I help?
Please, I'm sharing my screen.
Okay.
Hello, sir.
Yeah.
So I go to the line 30, the inspect.
Okay.
Yes. So when I try to run it, I got an error.
Okay. So first of all, let's see what have you saved anything as GR1?
ZR1.
Yes.
No.
No, you have okay.
GR, yes. No, here no.
Where did you save it?
No, I haven't saved it. So inspect.
Yes, so if you haven't saved it, how can you inspect it? So line 29 should be GR1, isn't it? Okay. So name line 29 as GR1.
Okay.
Before you can inspect it.
Okay.
Yeah. You are still having an error.
Yes, please.
Just a minute. Okay. Run line 29 again. Let me see. Just a minute. Okay, so line 29. So run line 30 again. Sorry, how do you call it? Line, yeah, so inspect. Why is it giving you error here? Because when you run line 29,
Yes.
Run it again.
Okay.
It gives you the rules.
Mm.
Just a minute. So when you inspect, are you sure you have GR1 or G? How did you say? Copy what you have on line 29 and come and put it into line 30. The GR. I don't know whether it's GR1 or GRL, how you've written it. So copy line 29, the name.
Okay.
Not the whole thing, just the name.
Please, which one? This one?
The GR1, the one you've done. The name,
This
the name
one?
of the object. Yes, the first one.
Okay.
No. You are copying the other sentence. The name, yes, that's the name. Copy it and come and put it into line 30, where you have the inspect into bracket.
Oh, okay. Yes. I made a mistake. It's GR.
That's what, yeah.
Okay.
So try it and let's see.
Okay.
Yeah. So it's working now.
Thank you, sir.
So, Doc.
Gregory.
Yeah, Doc. Please, I'm having a problem running the transaction aspect, the transaction
Hey, by
part.
this time you are at the transactions level.
I couldn't run it, so I stopped that. I stopped at that point, and I was following.
Okay, let me see. Share your screen, let's see.
Okay, please, I'm coming. Okay, Doc. Please, can you see my screen?
Yes, I can see your screen.
This right. I'm getting an error which says no method or default for coercing metrics to
Yes,
transaction.
I think somebody also had a similar thing. Okay, run line 9. Let me see.
Okay.
Okay, continue running. Okay, so run the matrix. Okay. Then the transactions. No method. Okay, no problem. So I think probably it might be, I don't know whether it's because of the version of R you are using. I'm not really sure why it's doing that. But the explanation I gave here was that most of the time you will not start from scratch like I did. You see the second example where we took the data straight from the database. Okay. In that instance, you don't need to convert anything into transactions. Everything is already in transactions. So you can still get your rules and then get your insight into the data. So probably, I don't know, if you can start R again for this particular one and see if it will work. Okay, but when you import the groceries, let somebody send you the syntax for the groceries, run it, and then let me see if everything will be okay.
Okay.
Yeah?
I'll
Okay.
do that.
Okay.
Thank you.
Okay, any other question?
Please, I have a question.
Yes. Please go ahead.
Please, I'm still at the beginning.
Okay.
I realized when I when I copied, what I copied is different from what I was seeing from my colleague's screen, on the screen. So I went to download again and copy straight from download.
You want to download what?
The glossary, shopping carts.
Okay. Did you use the code that we've been using?
Yeah, the set word.
No. The groceries was not. I didn't send you data set for groceries. It's already in R.
Sorry, the shopping carts rather. I'm still at the beginning. I'm not getting it.
Okay, share your screen. Let me see. Share your screen. Let me see.
Please, can you see it now?
Let me see.
At first, I used this very one.
No, that's what the person sent you. So that's the person's link. You can't use that person's link to open yours.
No, I did not use the link anyone sent.
Okay. So where have you saved
I went back.
Show me where you saved this work. Show me where you saved it. The shopping cart.
It here. Here is it.
Okay, so go to right click and go to properties.
Here is it.
Okay. Copy everything.
The location.
Yes.
Please, I've copied it.
And there, see something. Remember that. Go back. Remember that everything is in the shopping cart. Obviously, I think you've created a folder called shopping cart at the top. Okay. So be mindful of that. Okay. So let's go.
Okay.
So come and put it there. So come and put it into the set working W. Into the bracket. Put it on top of where you have the C. Just highlight the whole of the thing you have in line 8. Line 8.
Okay, line 8.
Yeah, just highlight the whole of it. Okay.
And paste it.
Yeah. And then remember that it should be in inverted commas. Okay. So go back. Yeah, but this thing we've done it long time.
Yes, so I realized it's supposed to be, but later on I realized
okay, and then change everything into front slash.
Front slash.
Please, we are waiting for you.
So I'm doing it.
Please, we are waiting for you. Christiana.
Sir, I'm done. When I run it, okay, now from the console, it's now getting blue. Now there's no problem. So, thank you very much, sir. Please hear me. Hello, sir.
Yes, Christiana, I think your internet went off.
Please, now with the inverted commas, I'm able to get it because from the console, it's indicating blue. So I think.
Okay. All right. Okay.
Thank you very much.
Okay. So now read it. Read it. Let me see that you've read it. Read it into R. Read your shopping cart.
Okay. So I should use the name and the AG, right?
Yes. I think you can use any name. Okay. And then the gets arrow. So read.csv.
Read.csv.
So pick it. Just click it. Into bracket. No. Open bracket.
Yes, open bracket rather.
Yes, and then inverted commas, and then bring shopping cart.csv. Check the spelling of the shopping cart because I think it was capital C or something. I'm not really sure.
Yeah.
I think it's
C.
capital S and then capital C.
That's C. Okay. Please say that's it. .cv.
.csv.
CSV.
Nana,
Can I run it?
The S.
The S is capital S.
Capital. Oh, thank you very much. Please, can I run it now?
Yeah.
Oh.
So see,
Christiana, the shopping cart.
The shopping cart, you've created another file directory called shopping cart. So what you need to do is that go back to line 8.
Mm-hmm.
No, go back to the end of the bracket.
In line 8.
Yeah.
Okay.
So after Nano said Boateng, bring another front slash and then write shopping cart. No, not after the inverted commas. Everything Should be within the inverted commas.
Within the inverted commas. Okay.
So after the Boateng, yes. So go and see how. Show me where you've saved this thing. Go to the go to the folder. Go to the actual folder.
Shopping cart is ART.
Yeah.
But is it in a folder? Is it in a folder?
It's in a folder. I have a folder for data science.
Everything is in BDA71. So there's no need for what you are doing. Okay, so go back to R.
Okay.
So remove the shopping cart. And then so run this now. Run the working. So
still shopping charts.
So
Christiana, please change the spelling. Yeah.
The shopping cart. Yeah. .csv. And then bring your inverted comma and then your close the bracket. Okay. Run it now.
Can I run it now?
Yeah. Okay, so it's working now. Please, you need to do a lot of practice. When we leave whatever we are doing, make sure that during the week you do a lot of practice. Because if you leave it like we did last week and then you are coming to it today, you still have issues. Okay.
It's because I got lost in the beginning. That confused me. Because I was working on it. Yeah. Thank you very much.
It's fine now. All right. Okay.
Yes, I'll continue from where we start.
Okay. All right.
Thank you.
You're welcome. So, all right. So, guys, are we okay? We are okay. Okay. So let's.
Please, can I see your screen?
Yes, you want to see my screen?
Yes, please.
All right. So that's my screen for you. Okay, so now you've seen how the a priori algorithm works. Okay, so at least now you have one unsupervised method under your belt now. Okay, so when you have transactions in a database, you can actually find out relationships between them. Remember that this is unlabeled data or unsupervised machine learning, which means that we don't know anything about the data. We are now going to find out. All right. So based upon what we've done, when we started, we didn't know any relationship that the item sets had in the database. But based upon what we did, we got more information. And now we have more insight into the database. So let's go on to another important unsupervised machine learning. Okay. Kindly put off your
Felix, please
microphone,
mute.
okay? Please. All right. So we want to dive straight into clustering. Clustering. So I'll share my screen later. Let's see where I have this. Oh, that's not what I need. Okay, just a minute. Okay, so we want to talk about clustering. Okay, clustering algorithms. Please, can you see my screen, Kumasi?
Yes, sir, we can.
Yes, sir.
Okay.
Yes, sir.
Right.
So, but it's not in the presentation mode.
It is. How are you seeing it?
We are seeing it in the presented mode, where we see both sides at the same time. If you can go to the display setting and then swap this, it might help. At the top menu, the display settings.
At the top menu, where?
On top, in the middle, where at the very top, the second option.
Yeah.
The second option, display settings. If you drop down.
This one, I'm not seeing what you are talking about.
So the display settings on the in the middle after the show taskbar, the display settings. If you click on it.
Just a minute. The one in the middle.
Yes, at the very top, there's a menu called.
Please, can anybody show me where the display setting is? They say I should click on display setting. I'm not like they are not seeing it the way we are seeing it here. So where is the display?
One of your colleagues to here. The display setting, which one? Because they are seeing it like this. Okay, so I think I'm told that's how you will see it.
Kindly go to screen in the menu where you are seeing the screen.
Okay. So apparently last week when we were doing it, they were seeing it like the way you are seeing it.
Okay, so sir, I'm trying to let us see the same way.
Okay, so you're trying to, all of us will see the same thing.
Yes,
okay.
Yes, please.
Okay, so I think he knows something we don't know. So come. So
Okay. Okay, let me yeah. Hello. So should we go out of this? Should we go
No,
out of
so
this?
just at the top, you see the show tax bar, there's display settings at the top menu. Click on the display settings. Do you see
anything at the top? Is it?
Okay, so you on the menu, just right click where you were, and let's go to, just click on the menu down there.
The menu.
The three buttons.
And now we can see.
Can you just take a screenshot? I've seen the display settings up there. Can you just take a screenshot on your phone, point the arrow to display settings, and drop it on the platform so it will be easier for
us. We are not seeing.
Yeah.
Okay.
Let me do that.
I think they are seeing it like this. Okay. If I open it straight, if I open the yes, then it doesn't solve any problem. Okay, so please, if you can take a screenshot like somebody was saying, send it to us and then we can follow, because we are seeing that one nice nice presentation mode here. So okay, he has sent it. Okay, right. So check it. Oh, but if there's a way to go about it, let's do it so that.
Okay, so I think if you want to convert to the presentation board so we all can see, the person that's sharing their screen on the Zoom, right? Go back and restart trying to share. When you are sharing your screen,
Where does it? Okay, so if you want it to stop sharing first, display settings.
Stop
Where is
sharing.
the display? We don't see the display settings. Stop sharing first.
You don't worry. Stop sharing.
Okay. So let's stop
and when you are
sharing.
sharing, when you are sharing, select the presentation view. You are showing us the other side of that. Yes.
Oh, okay. And then swap, duplicate. Duplicate. Yeah. Right. So now, if you share.
Yes, duplicates. Duplicates is the best.
Okay. So just try sharing your screen. I'll just share it again here. So now we can all see the same thing. Think that we don't share the screen of that. Okay, so you let me look at okay. So when it's like then share. Yeah. Now see it. Then see. Oh. Yeah. What you find there with tension and not share finally. What he wants, I've seen what he wants us to do. But it's not what. It's not possible to do. Okay. To understand it's not working here.
It's working now.
It's working now.
It's working now. We can see it clear. Thank you.
Okay, good. So that means the Kumasi people cheated you last week. Okay, thank you very much. All right. All right, so we want to look at class train. Class train, a very important unsupervised machine learning method. Okay, so after finishing this unit, we'll be able to explain the uses of class train, okay? And then we'll be in a position to compute Euclidean and Jaccard distances. Okay, we'll explain all that. Difference between hierarchical and non-hierarchical clustering methods. Look at k-means and hierarchical clustering algorithms, and then explain how a dendrogram is generated. Okay. Why are you smiling? We are looking forward to it. Why? It sounds a bit abstract. Okay. So, like we said, clustering is one of the unsupervised machine learning methods. Okay. And just like any unsupervised machine learning method, we don't know anything about the data. We are now going to see if there are some stuff in there that we can make sense of in order to help us make decisions. All right. And with clustering, we want to look at whether there are some groupings in the data. Okay, whether there are some groupings in the data. For instance, you might have a database. You want to know your customer segmentation, for instance, so that you can customize specific products for those groups of customers. Is that not so? Okay, so you want to get more information as to what are the subsets or what are the groupings within or segments within these data sets. Okay, and one of the ways by which we can draw these things out of a particular data set is to use a class train method. Okay, all right. So with that, we can reduce our data sets in a way. Okay, so data reduction. If we know groupings, then we don't, for instance, you have big data running into millions of rows. With classroom, we can group them into manageable sizes. All right, okay, and have a better understanding of the data. And then when we also do that, we are able to describe the properties of the data better. Okay, and then once we are also able to do that, then we put all, based upon certain criteria, we can put these clusters into, should I say, groups, suitable groups. All right. And then based upon clustering tool, we will be able to, or we can be able to detect whether there are some outliers in the data. Because when we group them, you know, there are some people who, they might not be in a group because of where they are located and stuff like that. Okay, so we'll be able to do all that. So by the time we finish this, you'll be able to see where you can reduce your data, okay, see where you can place your various categories of your data into clusters, and also identify any outlier that may exist, okay? So let's see this simple example where we have the observation and the features, okay? So now when I talk about the features, you know what I'm talking about. So each row describes an observation, isn't it? And then the features or the columns, these are like the fields. If you have a database, these are the fields or the characteristics of that particular observation. Okay, all right. So if you have something like this, at a glance, it doesn't tell you much. Okay, it doesn't tell you much. You have so many observations and so many features, okay? But when we begin to group them together, okay, so the ones with the heart and then the spade, and stuff like that, they are all grouped together. The data begins to make much more sense. Okay, so here you are seeing like 3 main groups, unlike the first one where there was nothing. All right, okay, so this one makes more sense, doesn't it? Okay, so clustering it has a way of helping you to manage your data better, okay, and then making sense of it. So it forms part of your exploratory data analysis. So you might have a data or a couple of data sets. Okay, you are now going into it to find out whether there are what you can find. So normally we call this exploratory data analysis. You are now coming to explore the data to see whether there's some stuff in there. And clustering plays a very important role. All right. Any questions so far on clustering? Any questions so far? Okay, so let's look at some definitions. Let's look at some definitions of clustering. So, you know, a cluster is a group, okay? A group or a segment, okay? And we say they are in a group because they are similar. They share similar characteristics, okay? Or they are close to each other. They are near. We will explain what we mean by near or close, all right? Okay. And then we have distance, okay? So distance, we use distance to determine the level of similarity. If we say something is close or near, then the distance should be smaller than where the distance is bigger. So if something is bigger, if the distance is bigger, then we say that it is less similar, if we can put it that way. But if the distance between two objects is very close, then they are similar. Okay, all right. So we will discuss the type of distance that we can calculate in order for us to determine whether something is similar or something is near or something is close. All right. And then we also have the space. We have the space. So we have two types of space, basically. Euclidean space and then non-Euclidean space. So Euclidean, like you're going like in a straight line, or something that you can use numbers to calculate, okay? We normally calculate it within the Euclidean space, all right? And then we have other ways by which we calculate distance, but it is not Euclidean. So that's why we have non-Euclidean distance and then Euclidean distance. So there's a formula for determining the Euclidean distance, okay? And also the formula for determining non-Euclidean distance. Okay. Centroid. So when we say centroid, know that with a particular cluster, the cluster will be in groups, isn't it? A particular cluster will be in groups. Now, the mean of a cluster or the center of that cluster, of each cluster, okay, is a centroid. So when you look at the average of a particular cluster, then that is the centroid. Because most of the clusters, they are around the centroid. You know, they come around the centroid, okay? They hover around the centroid, okay? And then we have the clustroid. So this is where it is similar to centroid, but here we're looking at a non-Euclidean space. So the centroid works in a Euclidean space, and then the clustroid works in a non-Euclidean space. So far, so good. Any question? Or I should go over?
Yeah, we are following, sir.
Okay, all right. Okay, so these are some of the terms you will be coming across. So some of the uses of clustering, I've told you, market segmentation. We can use it for HR. Okay, we can use it for HR. We can determine clusters based upon the interest of employees, demographics, gender, okay, skills, and so forth. Okay. So when we know that, then it will help us in our decisions when we are employing new people to come into the organization. Then we are looking for some particular skills, isn't it? All right. Okay. So clustering can be used in terms of HR stuff. Finance, for instance, if you want to look at portfolios of investment with similar characteristics, isn't it? You put them in a portfolio, okay? They are all forms of clustering. You are grouping them together. So in a particular portfolio, you could have, let's say, different investments or different clusters, have you seen, within that portfolio, okay? All right, so clustering can be used in finance as well, okay? So let's look at the flow of cluster analysis, all right? Sometimes you might need to pre-process your data. It's not every time, but sometimes you might need to pre-process your data. And then you select how you are going to determine your distance, okay? Is it Euclidean? If not, what type of non-Euclidean space are you going to use? Okay, then you cluster. You build a model to cluster. And then based upon the output that you get, you are able to analyze in order to give you some further information. Okay. So let's see the distance between two observations. Okay. So basically, when we say similarity, like I said, it depends upon how something is close to each other. So the definition of distance is 1 minus similarity. So when you deduct similarity from 1, if you compare, let's say, two different variables, okay, and then you deduct, you've calculated their distance, okay. Let's say if there's where we have similarity, let's assume that it is 1. If something is the same, then there's no distance. It will be 0. If it's also 1, then the distance here is going to be 0, isn't it? Do you get me? Okay, let's say similarity is 1. That means the same thing. Okay, then the distance will be 0. So in the same vein, if similarity is, let's say, 25%, that means that this similarity is what? 75%. The distance is 75%. That means that if you are comparing two things, one has similarity of 50%, the other one has a distance of 50%, the other one has a distance of 80%, then the one that has 50% is more similar than the one that has 80%. So this is the idea behind it. All right? Okay. So it's the same concept, but it's one side of it's like you have 2 coins, but it gives you the same information. If you know this, you can know that. If you know similarity, you can know distance. If you know distance, you can know, because the one is given. Okay. So let's see how we can calculate Euclidean distance. Can you see it? Okay, so the distance between X and Y, okay, is the summation, okay, the square root of the summation of squares between X, Y, and then to the X, Y, and then so many SYs as you have to the 9th, SN, and then the YNs. So let me go over it again. So you have a distance. If you want to calculate the distance, the Euclidean distance, you find the square root of X minus Y, then you square it. Okay? If there is X2, Y2, you find a difference, you square it. If there is X3, Y3, you find a difference, and then you square it up to SN, YN, okay, up to whatever number. You find a difference, and then you square it. When you finish, add all of them up find the square root, it gives you the Euclidean distance. Okay? It gives you the Euclidean distance. So let's consider, most of us like football, so let's consider how we can calculate the Euclidean distance between these two guys. Okay? The colors don't mean anything, okay? Those of you who love football will know what I'm talking about. So the colors, the colors don't mean anything. Okay, so one is at the center, okay? One is at the center. So the coordinate is 0, 0. So x is 0, y is 0. Okay? And then we have the one also where x is 12, okay? And then 9, x is 12, and then y is 12. So the red player has a position of 12, 9, or 12 feet to the right of the center and 9 feet up. All right? Okay. So let's look at the distance. What is the distance between these two guys? If you want to calculate the distance. Okay? Remember that x, okay, x, the blue player was on 0, 0. Okay? But the first figure is x, isn't it? The next figure, the variable is, or a value is y. Okay? This also shows the position of the player, of the red player, is 12, 9. Okay? So we have x and then y. Okay? So per our Euclidean distance calculation, okay, we are going to have 12 minus 0 squared, isn't it? 12 minus 0 squared, and then 9 minus 0 squared. We take 1y. Remember the formula here. Okay. So here, okay. So you see that we are this is the position of x, because we've used, you should be looking at the x, y here, because I've used different colors, so it's a bit, so don't look at it this way. Okay. So let's see here. So when you did that, so the other one is 0, 0, isn't it? So you take 1x of the first one, deduct the y component of it, and then the x of the second one, deduct y, and then find the, so you come to get something like this. So when you find the difference and then you square it, it gives you a Euclidean distance of 15. Okay? Or you can work it out and then see. Yes, I just explained that. This one is also xy. The formula. Sy. Remember, this is small xy. So the ones in blue and red, take it as the small xy. It doesn't matter because you are going to square it. So that's why you are square. It doesn't really matter which one comes first. When you square it, you get the same answer. Okay. All right. Okay. So the Euclidean distance. So the main thing is just know the formula. When you put it in there, it gives you the 15. Okay. So
Please,
you say? Yes, Christiana.
My hand is up.
Yeah.
Please, looking at the formulas, the first one is x1 minus 1y into brackets. So
yes.
And what we are doing, the next with the colors too, is x minus x plus y minus
yeah, that's
y.
why I'm trying to explain. That's why I'm trying. It's the same thing. That's what I'm trying to explain here. That the x red, and then the x blue is the same xy, just that I'm using blue and I'm using y. Okay. Don't let this one confuse you. Okay. Don't let this one, the blue person. The blue person. Where was the blue person? Was the blue person not at the center? It's not 0, 0.
Yes.
So this
Yes,
XY.
sir.
Is that not it? And
Yes,
then
I
the
understand
second
that
person
right.
too was 12, 9. So
Yes,
this
sir.
XY. All right. So
Yes.
XY and then XY. Okay. So you take the how do you call it? This X. And then this one too is also like that. Okay. So you take this, that's not all you have there. And then
So if I understand what you're saying, that means if you
the formula
change
says
it,
what?
it's the same thing.
Oh, that's what I'm trying to explain to you, that this X red X is just that probably the way I put it here that is confusing. But this X red and then X is actually XY. This is not XY. So probably next time I'll just change the naming so that it doesn't confuse you. I think that's where you are getting it wrong. But here is, you understand this is the coordinates. The blue is 0, 0. The first one is X. Second one is Y, is it not? This one to X and then Y. All right. So the location of this guy and then this guy. Okay, if you want to find the so you think that it's going to be X minus 0 minus 0?
Yes.
Yeah, that's what I'm thinking. Yes.
Say,
Because when you look at the first
Yes.
formula,
if I have turned this, I turn this the other way around. Okay, then probably I think that I will, when I'm doing I will change this one. Let the blue and then the red come here, and then you see the XY here. Please,
please,
don't let this.
Please, can you go to the previous
Please,
slide with the formula?
Wait. Let not this confuse you at all. Okay, let this don't. We will take on more examples. Okay, let not this confuse you at all. A simple Euclidean distance is xy minus x minus y, you square it.
yes.
Okay, all right, and then you have x2 s2 minus s2 minus y2, you square it. All right, and so forth. Okay. So if I have turned this thing round like this, okay. So if I have turned this one round, then you will see that it will give us the 15. Okay, so work out what you think is the right one. Let's find out the Euclidean distance based upon how you understand it. Work it out and let's find out the Euclidean distance.
It's 3.
It's 3.
Yes.
It cannot be 3.
No.
It cannot be 3. How did you calculate the 3?
I think it's 9.
It's no square root to cancel square root.
0 minus 0.
Yeah, it's 9. Yeah. Yeah, I think the 9 is correct.
No.
Yeah.
12 minus 9 squared.
That's hello.
Yes.
Okay, so if you want to go by, so that's a square root 0 minus 0 squared plus 12 minus 9 squared. So the 0 will discount that. So 12 minus 9, that gives us 3 squared.
Yeah,
I think what should have happened is that it's x red minus y red. Okay. X red minus y red, and then how do you call it? X blue minus Y blue. So just the thing that changes here. Yeah. Mm. No. You see, you could have situations whereby it's not just two people. So you can have, let's say, 15 people. Okay, you can have, let's say, 15 people. All right. So this formula makes it clearer that the first X corresponds to this, and then the second X corresponds to the other Y, and so forth. Now, all of them, when you calculate it, okay, will give you various distances. Okay. Do you know what? Let's not belabor this one too much. Let's take on other examples, and then you see, probably you are not getting this. Then you see, let's say, so the main thing, the main idea behind this is to find out data points that are near to each other. So the ones that are near to each other normally form a cluster. That is what this whole thing is about. So you might have so many Euclidean distances. You could have about thousands of Euclidean distances being calculated at the same time. Okay, so how does the algorithm form a cluster? It takes the ones that are close to each other, okay, and then forms them into a cluster. So that's why I don't want you to concentrate on just two players. You can have a situation whereby, so that's why this formula cannot be X1, SY, Y2, and so forth. Okay, so for this one is to the number of X and then the number of Y, whatever number that we have. Okay, and remember that this can be put in another form. This formula can be put in another form. So don't yeah. It will, what it does is that one cluster will have a mean, the distance, and then the others will form around that mean. Okay, but we could have, let's say we have five people. So it will calculate the distance between 1 and 2, 1 and 3, 1 and 4, and so forth. And then so the way permutation is done, so it will do for all these people, and then calculate. Probably if we go along, you will see a practical example, and then you'll be able to appreciate it. You say, yes, you need to get two at a time and then compare the distances between them. Is that okay? So you see that this one is two at a time. You can see, yeah. Yeah. It doesn't make a difference. You are squaring. See, You are squaring this, whether 0 comes before 12 comes. If it's negative,
yes, it's going to be positive.
Yeah.
They've not gotten it.
Yeah. So what I'm trying to explain to you on this is that if we make it S1, S2, this formula, the way it is written, is to explain to you that you can have various number of pairs and it will still work. So that's why it goes to the nth S and then the nth Y. You could have it could be millions, it could be thousands. So that's how this formula has been written. Okay, this can be written another way. All right, so in some books, you see the calculation of Euclidean distance is written another way. But just to visually let you know that no matter the number of data points that you have, so far as they are numeric, you can calculate the Euclidean distance. Is that okay? Okay. So, all right, so basically, if we are to do this, the distance between this, if we are to do this, obviously, you are not going to, R will calculate the Euclidean distance for you. Okay, so let's go to R quickly. Let's go to R quickly and just replicate what we have here. Okay, just replicate what we have here. Just create a vector X and Y, okay? So the X will be a vector of 0, 9, okay? And then Y will be a vector 0, 12, all right? And then just name it 2 players. When we are done, when you create the 2 vectors, okay, combine it in a data frame, and then use the dist function, okay, to calculate the Euclidean distance, and then see the results that it gives to you. So try this in R. Guys, try it. Kumasi, if you can hear me, try it and then see how it works. So your X will be your X blue, and then we have our S red. Okay. Are you getting the same thing? So you can open another tab, okay, in R. You don't need to continue with the association rule. Okay, you can go to File, and then R script to open another tab for you, new one for you, and you can save it as class string. Okay, so don't mess it up with the association rule.
Apology, no? Empire na be no. Come to me shank. There be also, but me show on phone. I'm watching it on my phone.
Nehemiah, go on mute.
Okay, so that one works for you, so you keep that. But the same thing, we calculated it in my slides and it's 15. Don't let that confuse you. Have you seen? Okay, you don't worry. You've So no problem. It's working for you, so no problem. So did you get 15? Kumasi guys, please, did you get 15 for Euclidean distance?
Yes,
Yes, sir, we did.
Okay. Let's create another one. Okay, now 3 players. Okay. 3 players. And now the vector for S, another player is on -2 and 19. So when you are creating
please, you are going fast.
So we are finding the distance between the 2 players. And then the method that we are using is Euclidean. Okay, put the Euclidean in inverted commas. Okay.
Yeah,
Is it working now?
So please, I'm still on it.
Okay, no problem.
Euclid. Say please, it worked. Thank you.
It worked. Okay, good. Yes. So now let's add another thing. Let's move to 3 players. Okay. So now for your X, okay, we want to add the position of the 3rd player, green. Okay. So see on my left-hand side, the green positions is -2 and 19. All right. So go and adjust the X, go and add -2 to your X, and then add 19 to your Y. Have you seen? And then create another data frame and name it 3 players. Okay, so when you do that, find the distance between the 3 players. So now it's going to find a distance between 2 and 1, 1 and 3, 2 and 3. Have you seen? Okay. Did you get the same? Did you get the same? Okay, so you see that when you calculate it for, so you can do this for so many number of players. Have you seen? So now you see that your 15 is still there.
Hi. Sorry.
Yeah, please raise your hand up, okay, so that we can get it organized a bit. Just a minute. So the distance between 1 and 2 is still there. It's still 15. Okay. And now it has calculated the Euclidean distance between 1 and 3, and also 2 and 3. Okay. So as and when the players increase, it will be able to do it all for you at the same time. Okay. Please, was somebody asking a question? Hello? Was somebody asking a question? Yes, Christiana, please go ahead.
Please say,
yes.
Why is it that we are still using the coordinates X and Y for the 3 players?
Yes,
but
that is their position.
But when I run it,
when you run it, what does it say?
Error in data frame X and Y.
Oh, you shouldn't be having error. Okay, share your screen. Let's see. You shouldn't be having error in your data frame. You are just adding something to your. When you added the -2 and 19, did you run it?
Yes.
Okay, let's have a look.
This is it.
Okay, so run 10 and 11 again.
Okay. Okay.
Is it working now?
Yes, it's working now. Thank you.
Hey, Christiana. I didn't want to run it, and it's not working. Okay.
It says it picked from the first one because I did not write it inside. I just brought a new thing.
No problem. No problem. I hope. Okay. See. Okay, so let's go on. Let's go on. Yes, a question. Two answers for. Yes, so the 19.10 is the distance between 1 and 3, player 1 and 3. And then 13.04 is the distance between player 2 and 3. Yeah. It's not 19. It's the same thing. It's the same thing. Don't worry, we'll go for break soon. Please, are we okay? Okay, so let's move on. Now, there are some times you need to scale your work. Okay? There are some times you need to scale your work. Because your features might not be in the same values. Or even if they are in the same values, some values might be so huge and others might be so small. If you don't scale them, it will just throw your analysis over the bar. Okay, so as a data scientist, you need to understand your data. That's where understanding your data comes in. So sometimes it is important that you scale your or you standardize, or sometimes you say you normalize your data. Okay, so that they are all within some parameters. So for instance, when you standardize them, there's a bit of difference. So when you standardize them, you divide it by the standard deviation. Okay, so everything that you get is between 0 and 1. All right, so with that, you're able to do comparison. But when you are comparing, remember that everything is being used in the context of a standard deviation. All right, okay. So for instance, the Euclidean distance between see the guy on the left. Okay, one weighs 200 pounds and another weighs 202 pounds. So basically, the distance is, let's say, 2. But this is different from when somebody is taller than you, okay, by 2 centimeters. Okay, so just taking a Euclidean distance will give you 2 in each case, but here the interpretation will be wrong. Okay, so you being the data scientist should know about this thing so that you can scale your data accordingly, so that it will reflect what is in the data. Okay, so it's not just about picking numbers and then calculating the Euclidean distance. You need to understand the data and whether there is the need to, standardize it or not, or to scale it or not. All right? Okay. Now, with the scaling, for instance, if we are to scale the height, okay, it's just the actual height minus the mean height divided by the standard deviation. Okay, so when you standardize it, normally your standard deviation is 1 and then your mean is 0. Okay, we'll take several examples you understand. But when we are scaling, so whenever you see scaling, you will not really calculate this. I will do the scaling for you, but this is for you to know that this is what is involved in. Okay, so with R, you just give the command to scale it, but you need to understand that this is what is okay. It takes the actual number and then deduct the mean and then divide by the standard deviation. Please, can you turn off your microphones, please? Okay. Please, is that okay? So let's look at the Jacquard distance. Okay. The Jacquard distance. So we've looked at the distance within a Euclidean space. Okay. We also have what we call the Jacquard distance. So first of all, let's see how these things are calculated, and then we come into R, and then we do some stuff. Yeah. So the Jacquard distance basically is used to calculate the distance between categorical variables. So here we are not talking about numbers. We are talking about categorical variables. Okay? But it's possible to determine whether something is similar or dissimilar. And we use the Jacquard distance. So it uses the intersection between A and B. So the distance between A and B is the intersection of A and B divided by the union of A and B. So let's see a practical example. Okay, so let's say we have two observations, okay, with 4 features. So we have wine, beer, whiskey, and vodka. Okay. I think next time I need to change the name and make it grapefruit and Fanta and soda. Okay, so wine, beer, whiskey, and vodka. Okay. Is any of them similar? What is the Jacquard distance? Okay. So what we are saying is that the intersection between A and B, so the distance between A and B, all right, is in the formula there. So here, 1 and 2 is the same as the A and B. Do you get it? So the intersection between this and this is when both of them are true. Okay, so let's see the first one. Wine and then wine. Yes, true and false. Okay, so we are not looking for that. We need where both of them are true. Okay, or both of them are false. Then we see that they are the same. Okay, so beer, true. Does it qualify? So 1, we put it down. Whiskey, false, true. False. All right, so here, both of them are true. Therefore, it is 1 out of the 4, isn't it? So the Jacquard distance will be 1 over 4. Do you get it? Should I go over it?
Yes.
Where you have true, that is the intersection. Here, A1 for observation 1 and 2, okay? True is for beer. So this is where they are the same, okay? This is where they are the same and truly the same, okay? All right, so that is 1/4. Okay, so it's 1 out of that. Okay, so if that is the case, that is our similarity, how similar they are. Okay, and we remember that we said that distance is equal to 1 minus similarity. So if the similarity is 0.25, then the distance, okay, between 1 and 2 is 1 minus 0.25, which is 0.75. Okay. Should I go by it? You're okay. Yes, Felix.
So say in an instance whereby we have both true and false.
Okay.
How will we solve it?
So here we're looking at a situation where both are what? True. If there will be 5. Yes, if they are 5, then it will be 5. But is somebody asking a question where they are false? What do you think will happen in that instance? What do you think will happen in that instance? Are they the same? False.
They won't be the same.
You say?
They won't be the same. So I was thinking maybe
why wouldn't they be the same?
because true is different from false.
True is different from false. Okay. That's a very wise answer. Okay. So based upon what we've done here, this is just to show you at the simplest level what is entailed in Jacquard. But you are not going to calculate it in R. So in R, when you go to R, all that you need to do is that, remember when we were doing for Euclidean, the method was Euclidean, okay? But here, we changed the method to what? Binary. Then it will tell R that you are measuring a Euclidean distance, okay? So where you have categorical variables like what we have here, okay, you can determine the distance by specifying your method argument to be binary. So it's still the same distance function, okay? This is the data, all right? So here, the survey is just this data that you have, these categorical variables, okay? And then the method is binary, all right? So you see that here, based upon this, it is able to calculate the distance between them. So the distance between 1 and 2, okay, is 0.75. Remember, true. Is it? Sorry, 0.75. And then, so here it does 1 and 2, okay, and then it does 1 and 3. Okay, so it will do this and this and this, and after that it will do this and that. So remember the first one that we did, true, is still here. Okay, so that is between 2 and 1, isn't it? So you see that between 2 and 1 is 0.75, like we calculated. All right. And then here too, there's another true here. That is between, and whiskey. That is between 2 and 3. True. So you see that between 2 and 3 too, the distance is 0.75. All right. Yes, please, you were asking. 1 and 3. One and 3 is true. Okay. The vodka. Okay, but remember that this distance that you see here, it's not just about true and true. It's true and true over something, and then they calculate the whole thing and then gives you, deducts from 1 and then gives you the distance. Okay. Yeah. Yeah. No, I don't get you. Yes. But see, now what will be the union? So just calculate it from per what we've done and see if you get the same answer. Because this one was just done in R. Okay, so based upon what we've done, you can also calculate it and then confirm whether we still have the same thing. Okay. Okay. So it's just this. So if you want to calculate between 1 and 3, you have the values. You can calculate it and then let's see. I'm sorry. Is this still not charging? Okay, it's charging now. Yes, please. If what? Wine was true. Yes. Yes. That will be 2/4. That will be half. Okay. All right. Are we okay? Kumasi, are we okay?
Yes, but in the next slide, it's like the calculation doesn't take into account the last, like when they are false.
Yes, somebody just answered the question. So if it's false, we are looking for true.
So like the item 1-3 0.6667, that one is
Yes.
like did it only 1/3.
Okay. So how
So I got when you do it 1 minus 1/3, that's when you get the 0.667.
Okay.
It's like the vodka doesn't take the calculation doesn't take into account the when they are all false. I think it takes it out.
Oh, so are you saying that is what you reckon or what? Or is the question you're asking?
That's what I think happened. Yeah.
All right. Okay. Okay, so let's go on to the clustering methods. So as for the distances, we'll come back to it and then we'll come and insert it into the clustering methods that we'll be using. Okay, so all that we've done is to look at both Euclidean distance and then the Jacquard distance. So based upon the clustering method that we are using, we will come and insert it into it and then it will give us, normally, if we the algorithm will require that we'll bring the distance. Okay, so once you know how to calculate it, we'll come and put it into it when we are running it. So we have two main methods, hierarchical clustering and then non-hierarchical clustering. Okay? So first of all, let's talk about non-hierarchical clustering. And one of, or the main non-hierarchical clustering, what we call K-means. 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 K-means clustering, okay? Or K-means algorithm. So it's a non-hierarchical clustering method, okay? It's a non-hierarchical clustering method. So let's see how it works. So first of all, it tries to find homogeneous items within the data set. So you start by, normally you start by indicating that I need 3 clusters randomly, okay? Okay, I need 3 clusters. So what the algorithm, the K-means algorithm will do is that it will just pick any 3 data points, okay? And then when it picks 3 data points, it will iterate. And when it iterates, it calculates the central point. So these 3 data points, okay, all the points that are near to it will form one cluster, okay, will form one cluster each. Let's say, so it forms 3 main clusters, okay. Then probably some clusters are nearer to other clusters. So if, let's say, one cluster is here, one cluster is there, one cluster is here, and then the first iteration, we do it, it divides it into 3. But upon the first iteration, it seems this cluster is nearer. There are some data points here that are nearer to some cluster, let's say cluster B. It will iterate again, and then it will move to cluster B, and then the centroid will recalculate, all right? And then check. It's still the same 3, but other clusters are still nearer to other clusters. It will iterate again. So it will iterate till the time the whole thing becomes stable. And then you will have your 3 clusters. Okay. So that is the, let me go over it again. So that is how it works, okay? Okay, so first of all, you select a K, any number of clusters that you want to work with, all right? Now, select K point at random as cluster centroid. So when you select it, it will pick its own random clusteroid, okay? And then it will start iterating, okay? So it will calculate the centroid of each cluster, all right? Then if you realize that, I think there are some clusters that are nearer to other clusters. So when the other clusters move to other clusters, then the centroid has to be recalculated, isn't it? So it will be recalculating until it reaches a point where all the clusters are in the correct places. There's no need to move from one cluster to the other, okay? So let's see this particular example. So you first do the first iteration, okay? You do the first iteration. You realize that for those in Kumasi, please, can you see my cursor?
Yes. Yes, sir.
You can see it?
Yes.
Yes, sir.
Okay, so you can see these data points. The one is on the line. Have you seen?
Yes, sir.
This one too is on the line. This one is quite near to these clusters than it is to these other clusters. But this is the first iteration. So let's say you say that it should divide this into 3. So it's done it. But this is the first iteration. So the second iteration, have you seen that this cluster, the one on the top here, has now moved to the one on the left? It has come to add to what you have on the one on the left, okay? But we still have 2 other clusters on the line. It's still iterating. So it does the third iteration. Then you see that these other clusters that were on the line, these 2, okay, these 2. When you come down here, you realize that, when you come down here, you realize that now it has moved to, the line, but the underside of left. Please, do you follow? Okay. Then it does the iteration again. So now here, when you come to the fourth quadrant, bottom left, you see that now the whole thing is stable. Then it will stop iteration and then give you that, okay, these are the clusters. So first it starts, it is not perfect. Have you seen some data points? You see that though these 3 points belong to the one on cluster, is it cluster B? Yeah, belongs to B, all right? But it is nearer these points. Okay, so it will iterate again and then correct itself and then move closer to where these points are. So it does that until it reaches a steady stage where even if it iterates again, nothing new is added to it. Then those become your clusters. Okay, so let's see a quick demonstration in R and then. So see this one before we go to R. So let's say you have this, let's say this information that you have here. These are a group of the ages of people who have visited your website. Let's say you've been able to get that data. Okay, it's about I think about 20 or something, or just over 20. Okay, but you've picked the date, the ages of everybody who have visited your website, for example. All right. So we want to create some clusters. All right, we want to create some clusters. Let's say just 2 clusters. All right. First of all, the initial clusters, the algorithm will just pick any age at random. All right. When it picks the age at random, it will do the first iteration. So you see that the first iteration, you have these ages, and I don't see clearly here. The first iteration, you have ages 15, 15, 16. 15, 15, 16. Okay. Now, the centroid for that is 15.33. That is the average of, if you add this and divide by 3, it gives you the centroid. Okay. Now, the centroid for the second cluster is 36.25. That is made up from ages between 19 to 65. Okay. So it will iterate again that I think there are some ages here that are nearer 15 to 16 than the 65 one. It will iterate again. And then now you see that 19 up to 22 have come to add upon the second iteration, has come to be added to the first cluster. And now the centroid has changed. All right. Now the centroid here is 18.56. And then the centroid for the second cluster is 45.90. It does the third iteration. Okay. Some numbers from here come to add here. And now the centroid for the cluster 1 is 19.50. Okay. And then cluster 2 is 47.89. It does the fourth iteration. It remains the same. 19.50, 47.89. Then it stops. Because now there's no need to add anything to it. So that's how the algorithm works. The K-means algorithm. So when we go to R, we will see how it creates it. But you will know that this is what is happening behind the scenes. Please, do you get me? Okay. All right. So let's create some data in R and then find the clusters. And then when we are done with that, then we can go for a break and come back. Yeah. What's the name again? Michael. So with k-means, you determine the number of clusters you want, okay? But there is a way of calculating the optimal number of clusters. Okay, we will come to that. Okay, so based upon your data set, you can calculate to see the optimal number of clusters that you should have. Okay, so it will not be just guesswork. All right, so we'll come there. Okay, so let's go to our R. Okay, I think I should open a new script so that we do use that for the plastering. Yeah. So K means clustering. Okay. So let's install some packages. So based upon what we want to do, let's install some packages. Let's install Flyer. Okay. Okay. And then when you are done, call it from the library. I'm showing you this. We are going to pick some random numbers, okay? In order for you to have the same results when you run it, you need to set what we call set seed. Okay, so you tell R that anytime you run that code, it should give you the same results. We are going to generate some random numbers for our k-means. But if we don't set the seed, anytime you run it, you get different, it will pick different random numbers. We want to use the same random numbers, even if you come back later. So you use what we call set.seed, okay? And then use any number, 10 or 100 or 1,000, anything, it doesn't matter, okay? So set it. So after you've done this, when we generate any random number, and we go back to R and we call it to bring the same random numbers. Is that okay? So set seed and then run. We want to create some numbers for X, random numbers. So it should be uniform numbers. So R unif. Let's have 50 random numbers generated. And then let's have that for Y. Another 50. So we want to have X and Y, okay? So let's do a column bind, okay? So my data, let's do a C bind, column bind, X, Y. So now when we call MD, we should have the X and Y combined, okay? So you see all the 50 random numbers we've created, okay, combined nicely like this. Okay. All right, so let's install. There are several ways to do the K-beans. I will show you both of them. Let's install animation package. So let's install animation package. Okay. So install.packages into brackets animation. Okay. Make sure you bring your inverted commas. So I have it already, so I will not install it. So when you are done, call it from the library. Okay, call animation. Yeah. Please, I'll go over it just in case you missed a step or something, okay? Don't worry. So let's run animation. Now, to the k-means, let's determine two clusters, okay, using k-means, okay? So determine two clusters using k-means. Let me make a comment. Okay, don't worry when you are done. So you can follow me. When you are done, then you write the code. So determine two clusters. By k-means. Okay, have I called it from the library? Okay. So let's call this KM, k-means, okay, KM. So it's simple. Your normal k-means, okay, it's just a function. K-means, all right, k-means, and then we take our data and then specify the number of k. It's as simple as that. Okay, run it. So it has created the k. Okay, it has created the k. So if you want to see other aspects of the clusters, okay, you can see KM $. It gives you other properties of the cluster. Okay, so let's see some of them. Let's see the cluster. When you run it, it tells you those data points and then the classes that they belong to. So let's say the first one belongs to cluster 1. We created how many? 2, isn't it? So the first one belongs to cluster 1. The second one belongs to cluster 2, and so forth. We'll find ways by which you can add this to the main data set so that you know where each point belongs to. Okay? So there are 2 main clusters. So out of the 50, you are seeing where each one belongs to. All right? So those are the classes. You can also find out more. So KM $, let's see the centers, the cluster centers. Okay, run it. So this gives you the centroid. So the cluster centers gives you the centroid of the clusters. Yes. Yes, so set your seed, and it's picking random numbers. But every time you run it, if you set to say every time you run it, you get the same random numbers on your laptop. Okay, so you see, have you seen the centroid? So when you go to the centers, it tells you, it gives you information about the centroid. So we have the centroid for X and Y for cluster 1, and then the centroid for X and Y for cluster 2. Now let's see, let's bring in the animation and then you see how the iteration is done visually. Okay, so this same thing, you can use the animation package that we did. Okay, so let's see. So using the animation package. So let's make this KM animation KMA. Okay, so it's the same thing. K means, but it gives you the option of .ani animation. Okay. Okay, it's the same thing. So you just specify the number of K. All right, you just specify them. So this time around, let's use, let's say 3. Okay, MD, the number of, or should we use 2? We should continue with the 2. Okay, so let's run it. So you see that, iteration, you see that it's being done. See that it's iterating. So whilst it's doing this, it's working behind the scenes to add the centroid, what we went through. Have you seen? You're smiling. Okay, so when it becomes stable, okay, then it will stop. Okay, so have you seen how it goes through? Kumasi, are you getting the same thing?
Yes, please. Yeah.
No, sir. Sir,
Okay.
I'm getting an error. It says error in plots.new. Figure margin is too large.
Okay. Is that Yao?
Yes, sir.
Okay, yeah, share your screen. Let's see what is wrong.
Okay.
So you can change the number of classes to 3 and then see how it iterates. You can even make it 4. Somebody is asking a question, so let them share their screen when they are done. Okay. Yeah, what's happening here? Please enlarge it a bit. Can't see, your stuff is really, really scanty.
Oh, okay.
It's not legible at all. Can you increase the font?
Let me change the background.
Okay, I'll change the background, yeah. But you still have to increase your font a bit. It's too. Okay, so what do you have here? So animation. So you run the animation, it ran, didn't it?
Yes, it ran.
Okay, let me see your MD. Let me see your MD. Run the line 49.
Okay.
Yeah, it looks good. And then, okay, so run line 64 again. Did you write the, is it K means you have there?
Yes, K means. I can run it again.
Yeah, so pick the, and then put the MD2. Yeah, run it again. Why are you getting error? Figure margins too large.
Please, can you increase the size of the window where the plots should show up?
Okay. Okay, so the size was too small for that. Okay.
Yeah.
Thank you. Thank you.
Reduce it even further. Bring it to the left a bit.
Okay.
You don't need a global environment. Just take it up a bit. I think you have issues with your.
I'll restart. Thank you.
Okay,
Thank you, sir.
so restart. Yeah. Okay. Have you tried other? Yes. Were you asking a question? Okay. So it's just comparing. You see that you have Y and then you have X. Okay. So further down the line, we will attach plus. We will attach it to the. We can use mutate. Okay, and then add it to the original data. So with each one, you see which cluster they belong to. Have you seen? So that means that you can filter using deep learning, you can filter each particular cluster and then delve deeper into it and so forth. Have you seen? Okay. Are we okay? Okay. What's the time now? 2. Really? 12.
12:43.
Let's do another example and then we go for break.
12.
12:43.
Okay, all right. Yes, Christiana.
Please say, when I did my I couldn't see the plot.
You say?
I couldn't see the plot, but it did not give me any error too.
Okay, Christiana, share your screen.
Maybe she has
Christiana, everybody knows you in
presentation.
Accra. I think we'll make you the class prefect of Accra. Everybody
I'm not
knows
in Accra, Osei.
I know
I'm
you are in Kumasi. Yeah.
Please let me share my
By the
screen.
time
So
by the time you need to sponsor her, get her a plane ticket so that you all see her face. Very lovely woman. Okay, Christiana, please share your screen. Let's see.
please, can you see it now?
It's coming. Yeah, so what do you have there?
They're using the animation.
Yeah.
Yeah, when I run it, it's giving me error in plot.new something something something.
Okay, did you call it from the library? Call it from the library, let me see. So it's working fine here. Okay. Okay. So run line 36, let me see. Yes, it's running.
But sir, it's different from what I saw on your screen.
It's not different. Just because I had you see, I moved my how do you call it? My quadrant a bit up. That's why you see that mine is a bit larger. Okay, by the
All
same
right,
thing.
thank you, sir.
Okay, you are welcome. Okay, so let's take an inbuilt data set from R. It's an interesting data set. Okay, so let's do another practical example. So this time I want to use it on the iris data set. Okay. Oh, okay, I'll give it to you. So you see, when you type data set, have you seen, with double full stop, it gives you the list of all the inbuilt data set in R. Okay. Yeah. But for now, we need the iris data set. Okay, so data iris. Okay, so when you call iris, it's a very interesting data set that tells us different flowers and some features of the flowers. Okay, so probably let me use view so that you see the whole thing. So you see that it has different types of species. Okay. Okay. So these are we have Setosa. Let me just do a summary of it so that we can see. Well, it's just a minute. Okay, I'll be with you. So in terms of species, we have Setosa, Versicolor, and Virginica. Okay, so these are 50-50 each, all right, of different flowers, okay? And it's giving us the length and everything of these flowers. Okay, so we want to see if we can cluster them, all right? All right. Please, was somebody asking, I saw somebody's hand raised. Are you okay?
Yeah, I am.
Okay, all right, that's fine. So we want to, we are only interested in the species, okay? So let's use our dplyr, okay? So bring in your dplyr, call it from the library. Okay. So let's have a glimpse of this, of iris. So you see all the information that we have here. So we are interested in the species. Okay. So it has different features. All right. It has the length, the width. Okay. So we have sepal length, sepal width, petal length, petal width, and then the species. All right. We are interested in the species. Okay. So let's just select the species. We are interested in the length and then the width, but we are not interested in the species because it has been grouped already. So let's remove it from that, and then let's see if we can create other clusters, okay? So our new one is, let's create iris new. So we want to create a new data set out of this, all right? So if you remember, we take our main data set, that's iris, and then we pipe that. We pipe that into select. Now, last week, I think when we're doing it, we specified the ones we needed. Okay. Another way to go about it is to specify what you don't need. Then it will give you what you need. Okay. So we want the petal length and width, and then the sepal length and width. We don't want the species. Okay. So you can say minus species. Okay. Remember that it's capital S. Okay. So minus species. All right. So let's run it. Okay. I'll go over this very soon. Okay. Minus species. So now we have our iris new. Okay. So let me make a comment here. So create new data set. Create new data set without the species. Okay. All right. So that when you are going through, you can remember. Okay. Right. So let's have a look at our new. We can have a glimpse of our new iris data. So we have iris new. Okay. So you see that it has removed species. So now we have sepal length, sepal width, petal length, and then petal width. Okay. All right. So let's create 4 clusters from this. So we're using the k-means. So cluster K, you can give it any name that you want. So it's very simple. It's k-means, data, and then a number of clusters that you want. It's okay. So k-means data. Data is what? Iris new, isn't it? Iris new. And then the number of clusters. We want 4 clusters. So let's run it. So now we have created the clusters. Let's see the cluster size. So cluster K. So if you want to see, then you bring the $sign. All right. So the $sign opens up other properties of the cluster that you can check. Okay. The total sum of squares and within squares, will come to it later. Okay. So let's see the size, cluster size. Let's run it. Okay. So these are the sizes. So 4 clusters. So that means you have 32 in the first cluster, 28, 40, and then 50. Okay. So this is the size. Let's see the cluster centers. It doesn't matter because your what order does it have? 15, 50. Okay. All right. So let's see the clusters, cluster centers, the centroid. Okay. So cluster center. Let's see the centers. Yeah, Melody, I'll be with you in a minute. So let's run this. So these are the centers. Okay. Let's see if there's another thing there that we might be interested in. The number of clusters, okay? The clusters themselves. Okay, so it's giving us the numbers, the cluster numbers of what each one belongs to. Okay. Yes, Melody.
Hello, yes, sir.
Yeah, please go ahead. You wanted to ask a question.
Sir, for me, I'm lost because when I did using the animation,
okay,
when we determine the two clusters using KMs, using the animation,
yeah,
the animation I got is quite different from what you are showing. So,
yes, because it might be different, but it's because your laptop chose a different random numbers.
Oh, okay.
Okay, so remember that the if it's random uniform numbers, this one in line 6. So mine might be a bit different from yours.
Oh,
but
okay.
it gave you two clusters, didn't it?
Please let me show you my screen. So
okay,
let me
show
share
me
my
your
screen.
screen. Okay. We are waiting for you.
Yes, I can't see what I want to show.
Okay, for those who are done, see if you can add the clusters, okay, to the main Iris new data set. Create another column, and then so that when we pick one, we will know which clusters they belong to. I'm coming. Somebody asking the question. How are you going to go about it? Oh, you forgot to mutate. Mutate. Okay. And then you bring the name, and then the name will be equal to the cluster, you know. Okay. So give a name to the cluster. Okay. Give a name to the cluster and then work. Try it, and then I'll come around and see. So you are going to add it. So the clusters is four clusters, isn't it? So you are going to add it to the main data set. So that when you take each observation, you know which clusters they belong to. So after we've calculated your clusters, okay, after you've calculated your clusters, K, when you do the $sign, and then you pick clusters, and then give it a name. So that name is equal to that clusters. And then when you finish, go and mutate and add that name to your Iris new. Now you are doing data science. Now you are being baptized into it proper. Okay, I'll come and see you. Please, what's the question, Melody?
Hello, Doc. Can you see my screen?
Yes, I can see your screen.
Look at my animation. What came? So I don't know.
Okay. Run line 13 again. Let me see.
Yeah.
Okay, we are good. Run line 16. Go on. Your normal K means. Okay. Continue running. Let me see. Okay. Yeah. Okay. No, I see what is happening. Your Y. You just use line 7. You just use 50. You didn't use the random uniform numbers.
Okay. Oh, okay.
Yeah. Okay. So do it and run it again. Yeah. So run through it again.
Okay, sir.
All right. Thank you. Okay, I'm coming. What's your name? Amma. So please, why is very case sensitive? So every time you check it. Other than that, you run it there, you don't know where it is. Okay. But seriously, you're all doing well. Okay. Yeah. 2 weeks ago, you were that.
Please, question.
Okay. But why people are ready to install it the last time? Yeah. Before you do it, coming from somewhere. So I always give high